Assalamualaikum. Hi, we are in class MEC 294. Today I will elaborate more on the second experiment of thermal fluids laboratory T2, which is Boyle's law. And before we going through the experiment and go through this lab sheet, I would like to explain on the theoretical part of the experiment, which is very important before we conduct the experiment, so that all of you can have some ideas on what is this experiment all about. Okay, so we first read the objective first of this experiment, which is to determine the relationship between the pressure and volume of a gas with fixed mass at a constant temperature. So basically we have two important parameters here, which is pressure and also volume. Okay, and we will relate this two parameter, which is part of the Boyle's law. Boyle's law. So basically, from the theoretical aspects, the Boyle's law state that at a constant temperature for a fixed mass, okay, the absolute pressure and also the volume of a gas are inversely proportional. It means that when the pressure is increased, the volume will be decreased, and also it can be on the reverse, vice versa, which is if your pressure is reduced, your volume also can be increased. So if you see here, this is the relation between the pressure and also volume, which is P is proportional to the 1 over V. P is a symbol of the pressure, okay, and also V is a symbol of a volume. Okay, so besides that, it also can be said in a two form of statement, which is first, pressure is inversely proportional to the volume. Second, you can also say that pressure is proportional to the 1 over V. Okay, so this is two statements, but in terms of the equation, it still produces the same equation, which is P inversely proportional to V. Okay, so from this equation, the pressure shall be increased when the volume of gas decreases and vice versa, given that the temperature of the gas and the mass of this gas is constant throughout the process. So the mass and also the temperature is your two important parameters that should be constant throughout the experiments. Otherwise, we cannot say that these experiments will follow the Boyle's law. Okay, so some students asking me where this question comes from. So basically it comes from the experiment law, which is Boyle's law, and then this Boyle's law basically will lead to this equation, which is PV equal to constant, because during the experiment it get the previous relation, which is pressure increase, volume down, pressure down, volume increase, and this important equation PV equal to constant, or I will just write in terms of a PV equals C, will lead to the famous equation, which is ideal gas equation. Okay, so we will go into this ideal gas equation later, but this Boyle's law is a part of this ideal gas equation. Okay, so in terms of the relation between state 1 and also state 2, when we apply it in a two different parameter or two different set of parameter, we will get a P1 V1 equal to P2 V2. Means that the multiplication of the data set at a time, okay, P1 multiplied with V1, you will get the same value when you change the value of pressure, so that you will get the constant value if you multiply with it corresponding volume. Same like the next data set, which is if you wish to get a P3, you apply P3, so you will get V3, and if you multiply this P3 and V3, you will get also the same value. So I will just write this as a Pn multiply with Vn. Okay, So this is equal to constant value. So this is we call as the Boyle's law, which demonstrated using a fixed mass and also in a fixed temperature. Okay. Right. So in terms of the characteristic of the gas, when we do the experiments, we can imagine that we do the experiment in a piston cylinder device, such as in this picture, as you can see in the screen. All right, so we have two different picture, which is on the left side and on the right hand side. So the left side will show you the Boyle's law experiments when the volume is higher than the right one, and if you see when the volume is high, the pressure value there, which is come from the pressure gauge, will show the higher value as compared the pressure is lower as compared to the right hand side of this picture, which is if you see the volume is down, your value of your pressure will be higher than the left one. So this is what you will expect when you run the experiments. Okay, so in terms of this equation, since we get a PV equal to constant, so if we plot the pressure and also volume, okay, P and also V, you will get this inverse relation which relates this equation. So you can also imagine this like equation of y x equal to 1, okay, because during mathematical expression we always express in this equation, which is also considered to be same like y equal to 1 over x. And if you review back your mathematics books, this equation, you will get this kind of relation when you plot y versus x. So basically this is a common, if you run your experiment, you will expect to have this kind of shape after you plot the data set between pressure and also volume. Okay, so now I will explain more on the part what is happen inside the piston cylinder device. Okay, so I will sketch this piston cylinder device. Alright, you see on the screen. Okay, so inside this piston cylinder device, basically we have some particle of gas. Okay, and we know that the characteristic of the gas, it will move randomly. Okay, so I will use different colors here. Maybe this one. It will move in any direction here. Okay, in any direction. Right. So each of this particle of this gas exerted a force on the wall of the container. So it will exerted on the wall. So every particle this will contact with the container. This container or this cylinder have the surface area, and this surface area will produce F over A, which is your pressure, which is equivalent to the F force per unit area. This is due to the collision of the gas atoms or molecule with the wall of the container. So if you have a higher force, you will produce higher pressure. Okay, as the motion of the gas particle is completely random, right, as I said, the pressure exerted at any position of the surface is the same. So basically in fluid mechanics, you have experience of this F over A, which is pressure of the fluid, and the magnitude of this particle will always to be constant throughout the system. So the pressure at any direction here, in any position, will be same inside the piston cylinder device. So if I change the piston moving upward, what will happen is that right, when I increase the volume by bring the piston upward, what will happen inside this system is that the volume of the gas will be increased. Okay, and basically if you refer back to the relation of the Boyle's law, if we reduce the volume, what will happen to the pressure? Your pressure will be lower if you increase the value of the volume. And also if I reverse this process, okay, which means that I bring the piston downward, okay, piston downward. Okay, so what happened to the boundary of the system? The boundary will be smaller. Okay? So the volume is reduced. What will happen to the pressure? The pressure will be increased. So this process we call as the compression process, while the previous one here we call as expansion. Okay, the expansion is correspond to the increment of the volume, while the compression is correspond to the decrement of the volume. Okay, so in this experiments we will focus on these two parts, right? So why the pressure is increased and why the pressure is reduced? Okay, so let I explain more on this part. If you go into this picture right now, so every particle here, if we increase the volume, it means that the mass is still same, but the distance between the molecule will be high. So it means that the collision movement is also reduced because there are slightly lower or less contact between the molecule or the particle or atom of the gas. Okay, it's not same like the compression. If the compression is occurred here, most likely the atoms will move or will go more collision here. Okay, collision is higher. As much more collision is high, the force between them is increased and the pressure will be higher. Okay, because the pressure is equivalent to the force per unit area. So it is depend on the collision between the atom or particle of the gas. Okay, something like that, right? So however, the condition of this Boyle's law must make sure that the mass and also temperature should be constant. If your mass is not constant, it will be different value, and if your temperature is high or lower, it means that there are extraction or the increment of the energy, and it not suitable for the Boyle's law to be followed. Okay, so that is about the characteristic of the particle of the gas. So now we look back on the lab sheet here. Right, so as I said previously, right, the Boyle's law will lead to the famous equation of ideal gas equation. So basically, the ideal gas equation is equal to PV equal to mRT, which is comes from the three equation, and one of it is Boyle's law. The other two is Charles' law and also Avogadro's law. Okay, so we focus on this Boyle's law only. So basically, if you look at this ideal gas equation, PV equal to mRT, which is P is your pressure the unit is kPa, volume unit is meter cube, m is mass, r is a gas constant, kilojoule per kg dot k, and the last one T, temperature. The unit must be in Kelvin. Okay, so as Boyle's law said that the pressure and volume is inversely proportional with the condition of mass and temperature is constant. So if you look here, two parameter already constant, and then your R here, okay, is already constant also. Okay, so on the right hand side of this equation, basically m, R, and also T, these three parameter is a constant value. Okay, so I will just write this multiplication of m, R, and T as a big constant C. Okay, so my equation now becomes PV equal to C, and this is related with the Boyle's law again. Okay, so in other equation, which is number of moles for this ideal gas equation, which is PV equal to N RUT. Okay, so this equation also related to the Boyle's law, but the only difference is the number of mole is replace the mass of the gas. Okay, so the pressure is still same, V is still same, temperature is still same. The only difference is N also RU. N is a number of moles, so the unit basically can be mole or kilomole, and this RU basically we call as universal gas constant. Okay, so the relation between R here on the top of this equation, R and also RU, is the molar mass. Okay, so it can be related like this one. R is equal to RU divided by M, where this M is a molar mass. Okay, so you can find the value of molar mass in the appendix. Okay, which relate the value. It will give the value of the molar mass for different type of gas, same like R. Okay, but your RU should be constant. The RU will be equal to 8.314 kilojoule per kilomole dot Kelvin. Okay, so you can also look here, 8.31447 to be exact, kilojoule per kilomole dot Kelvin. Okay, this should be same with other gas, because this is universal. It can be used for any gases. Okay, so you can use this equation to relate with the Boyle's law, or you can use with the first one, PV equal to MRT. All of these two equation is valid. Alright, so that is a part of the theoretical aspect for this Boyle's law. So now we go into the data or result on how to fill up the result for these experiments. Okay, if you see here, there are two tables to be filled. The first one is the compression of this gas, and the second one is the expansion of the gas during the Boyle's law experiments. Okay, before you want to fill up this table, you need to understand first the procedure and how to conduct the experiments. Okay, you can follow or look at the link for the other on the procedure. So there are also video on the experiment on how to do the experiments, but there are slightly different equipment, such as our example just now. Okay, for example, our example that I have explained just now is use the piston cylinder device, but your equipment in your laboratory is not use the piston cylinder device, but instead of using the piston cylinder device, it use the measuring cylinder. Okay, so there are two measuring cylinder here. Sorry, the first one on the right hand side is we call as the measuring cylinder. On the left hand side we call as the pressurized cylinder. So the mechanism is slightly different, but the objective is still same, to run the experiments related to the Boyle's law. So you need to focus on the right hand side. Sorry, I use the right red pen here. Okay, on the right cylinder here, because it will give you the value of your volume and value of your pressure and also temperature. So this is the measuring cylinder. The left side of this cylinder is called as the pressurized cylinder, where you want to top up the oil, or you want to transfer the oil from one side to another side. Okay, so if you look here, the oil will flow, and this will fill up part of the cylinder. So as the volume of the oil is increased, volume of the air will be reduced. Okay, for example here, we focus on this volume of air. Okay, so initially it will be 0 like this. Okay, so the air here will be compressed or will be expanded. Okay, so if your volume of the oil is increased, volume of the air will be reduced. Means that this is a compression process, because the air is compressed, or it will be compact more. Okay, and if you want to do the expansion process, we just bring out back the oil from the measuring cylinder, so that you have the higher volume of air. Okay, and then this we call as the expansion process. Okay, so you need to look at the measuring cylinder scales on what is the value of the volume of the air, and also the value of the pressure and also temperature. However, you can look at the control panel to see the exact value of the pressure and also temperature, because this is the control panel which is linked with the pressure sensor and also temperature sensor there. Okay, so if you look at the startup procedure, there are important step here, which is a startup, and also when you run the compression process, you need to record first the initial pressure reading of the PT101 and also T101, which is on the right hand side of the cylinder, which is a measuring cylinder. So this will lead you to the pressure and also volume of the initial, where there are no compression, no expansion happen. Okay, so this is important, so that you know the value of your mass, okay, by using the equation of PV equal to MRT. So you need to get first your mass. Okay, after you switch on the compressor, so it means that the compression process is happen. As the compression process happen, means that the oil will move here, okay, to fill up part of the air, and it will increase, and then it will increase. Okay, as more oil is put into the measuring cylinder, it means that your volume of air is reduced, but your mass is still constant there. Okay, so because this is a closed system, and there are no leaking, and so this is your assumption no leaking, so to make sure that the mass is constant. And at the same time, when you run the experiments, you need to make sure that your temperature should be constant. So you will see a slightly different value of temperature, but the value should not to be large. So I think the value should not higher than 0.5 degrees Celsius. Okay, so If it is higher than 0.5 degrees Celsius, means that there are more heat loss to the surrounding, and the Boyle's law will not validate with the theoretical, between the theoretical and also the experimental lab. Okay, so now we after you get the mass, and then you can go follow the procedure here. Okay, and then make sure you do the experiment according to the table, right? So if you get the initial pressure here, basically let's say at 2.5 liter, you get the pressure to be 0, let's say, which this is 0. Okay, the temperature, let's say you get it's around 30 degrees Celsius. So 30 degrees Celsius, you need to change into Kelvin to get to use the equation or ideal gas equation. So you plus with 273.15, you get 303.15 Kelvin, and then you need to redraw back the table using the Kelvin value. Okay, so you have you have volume, you have experimental pressure. Okay, you have the theoretical pressure, and then also you have temperature. Okay, so let's say initially you have 0, you have volume the 2.5 liter. So this one I really suggest you to use the meter cube lah. So if you use the meter cube, 2.5 divided by 1000, you get 0.025 meter cube. Sorry, 0.0025 divide by 1000. 0.025. Okay, 0025. Alright, so 303.15 Kelvin. Okay, okay, so this pressure should be in kPa, should be in kPa. Okay, so after you get the pressure, let's say the pressure is 0 when you record the first or initial value. So you need to calculate first the mass, which is PV equal to m RT, and you rearrange this equation. M equal to PV divided by RT. Okay, so so you can find your R first, or you can also use the simple equation here, which is already given, the density or R. Okay, whenever you like, whatever you like, you can use this. So the density is 1.292. Okay, you can use this rho V. Okay, 1.292, and then you need to get your volume there, 2.5, sorry, 0.0025. Okay, okay, so now you just multiply 1.292 and 0.025. Bring my calculator first. Okay, so what value you should get? 1.292 times 0.025. Okay, so you get here 0.0323 kilogram. Right, so using this equation, you can find the theoretical value of your pressure, PV equal to MRT. Okay, so PV equal to MRT, right? So becomes P equal to MRT over V, which is 0.0323, multiply with R. R is we call here 0.287, right? Okay, and then you have a temperature, then divide by your volume. Okay, your volume is 0.000025. Okay, I think 0.025. So it should be 0.003, 0.003 also, 0.00. Okay, so you can calculate your theoretical pressure there. So 0.00323 times 0.287 times 303.15 divided by 0.0025. So you get here as 112.41 kPa. Okay, so this is your initial pressure. Okay, so the value might be different like the experimental pressure, because this one is 0. We're reading from the pressure gauge. So the pressure will give the gauge value. So you need to add with the absolute pressure to get the you need to add with the atmospheric pressure, okay, to get the absolute pressure. So if you see here, you need to use a standard thermodynamic pressure. Okay, so let's say the atmospheric pressure P atm to be 101.325 kPa. So if you get the value as a 0 kPa here, you need to add with 101.325 to get the absolute value, and then you can compare between the theoretical and also experimental pressure. Okay, besides, after you get the first P1 here, so you on the compressor, so the pressure will be increased and the volume will be reduced. You can relate using the Boyle's law, P1 V1 equal to P2 V2 to get the value of the theoretical pressure of P2. So you just rearrange here, P2 equal to P1 V1 over V2, so that you already get 112.41 here, multiply with 0.0025, okay, divide by the next volume is 0.00224. Okay, so theoretically you will get 112.41 times 0.0025 divide by 0.0024, which is equal to 117.09 kPa. So as your V2 is reduced from 2.5 liter into 2.4 liter, you will see that the increment of pressure from 117 kilopascal from the initial pressure, which is 112.41 kPa, and then you can fill up this pressure here, sorry, the theoretical pressure here correspond to the volume. So the same step like the expansion one, so you just follow my step here and you will see the answer, okay, using the same method. Alright, so that is about on how to fill up this table and complete the experiments. So after you complete this table, you need to plot the graph, okay, between the pressure and also temperature. You plot for the compression and also expansion. So let's say for the compression one, P versus V here, most likely you will get this kind of shape for the theoretical pressure versus volume. Okay, so make sure you have the units here, and then you plot using the Excel. Okay, so this is the theoretical. All of the values should lie on the line, but you need also to plot the experimental value here. So most likely you will not get the exact value like the theoretical value. So sometimes you get like this value, and then you need to use your Excel to fit the curve, the best curve. Okay, so it can be like this, or it can be on the bottom of this pressure also. It depends on your experiments. Okay, so make sure that when you sketch or draw this curve, right, you need to fit the curve using the polynomial fit. Okay, then you get this right curve. Okay, and it must correspond with the Boyle's law, which is if you increase the pressure, your volume will be reduced, and also if you increase your volume, pressure will be reduced. Okay, so I think that's all about of these experiments. Okay, you can answer several questions here on the discussion part. Okay, to get more better understanding, and also you can do the activities to label the apparatus, and also some items in the apparatus. Alright, so see you on the next experiments. Thank you very much. Assalamualaikum.